Hello everyone, welcome back to the video for my mock test I took, and I couldn't solve number 23, 24, and 25 because I didn't have enough time, and I was actually scheduling to take this video tomorrow, but I just decided to do it today, and yes, so let's try with number 23, 4, 5. I actually couldn't try these problems yet. This is my first time trying them. 25, I read it while taking the mock test, but I couldn't proceed further. So 23, an arithmetic sequence of positive integers has n. Curry wrote down all the terms in this sequence correctly, except for one term, which was off by 1. The sum of the terms he wrote down was 2 to 2. What is a plus c plus n? Okay, so we have the terms a plus d, 2d, until a plus d times n minus 1, right? And when we add all of them, how many a's do you have? We have n a's, so a times n plus d times 1 plus 2 plus 3 plus until n minus 1 is n times n minus 1 over 2. Was off by 1. So plus 1 equals 2 to 2. Wait. Off by 1 means it can be plus or minus, right? Because it means that the value that Curry wrote was just a wrong value by 1. Our first case is when plus d times n dn n minus 1 equals minus 1 and multiplied by 2, so 4, 4, 2. And the second case is when 2an plus, why am I keep writing a sub n plus dn times n minus 1 equals plus 1 and 4, 4, 6. Now let's factorize this. Then we have 2a plus dn minus 1 equals 4, 4, 2. Now, you know what, actually, let's write it like this. And then stop here, and then 2 times 2, 221. What is 221? It's not divisible by 3, 5, 7, 11, 13, maybe? Is 91 divisible by 13? Yes, by 7. So this should be 13 by 17. Is it right? 97. Yes, it is right. And 223 is not divisible by 3, 5, 7, 11, 13, definitely not. We check everything that's within 15, so 223 is a prime. Now, I'm pretty sure this case doesn't work because n must be 223, but this whole thing cannot be equal to 2. Because d is greater than 1. So let's eliminate this case. Our first case is here is when n equals 13 because n must be greater than or equal to 3. So 2a plus 12b d equals 34. Here d equals 2, a equals 5. The second case is when n equals 17. 2a plus 16d equals 26. D equals 2, but this doesn't work. So from here, it will not work. Then the only choice is n equals 13, a equals 5, and d equals 2. So adding them up, we have 18 and 20. I think that is the answer. Let's check. No, why does it feel like 22, 23, 21, 22, 20, like 19 to 23 easier than, yay, we got 20. How did, they used the formula. Wait, I could have used the formula. I cannot believe that I didn't use the formula. Everyone here used the formula. I didn't use it. But anyways, it's strange that it feels like number 19 through 23. It is easier than like number 13 and 14. I mean 13 was like not bad, but like number 14 is easier than number 14 for some reason. Okay, number 24. What is the perimeter? Perimeter of the boundary is a boundary of the region consisting of all points. Okay, I don't like these kind of problems. But I mean, AMC 10, I think it may be doable. So let's find our range first. We have 2u minus 3w less than or equal to 2, greater than or equal to -3. V plus 4w less than or equal to 5, greater than or equal to 0. So let's graph them. Our y is between. Okay, before I do y, let's do x first. I think that's easier to draw. We have 2 here, 3 here, 0 here, and 5 here. That doesn't look like a 5. A little higher? Yes, this is 5. So all the points lies within here. But that's not what the problem maker wants. The problem maker wants a smaller boundary. Okay, so first thing first, we know that u, v, and w are independent, but x and y are not independent. They're dependent because they both include w. No, I won't say x and y are entirely dependent to each other, but I just want to say that they share w. Let's use that property. So first case, when u equals 0, v equals 0. Then we have all the points, and the reason why I did this is because u and v are like independent and there's no u in x, y and no v in x. Maybe if we find this trivial solution, then we can transform our things. So w equals 0, it will be here. W equals 1, it is here. Wait. Wait. Will it just be a straight line? Maybe? Because the reason is because, like, for example, substitute 1 over 2, it's just half from here, so like half. 1 over 3 is 1/3 from here, 1/3 from here, and that's just a property of a linear function. But to make it more rigorous, let's try and prove it. So we have y equals rise over run. This is the equation of the line. I mean, like the partial segment. No, this is not the equation for the segment, but the line that includes this segment. And there's only one line that satisfies that. Let a comma b the points on this line. Then we have a comma negative 4. Let w equals negative 1 over 3a. Then we have negative 3w comma 4w. So we just proved that it is actually indeed a straight line. Okay, now from here, let's transform. We are going to increase, should we change our, I think y value seems easier. So we increase by 1, we increase by 1. So we have another. So this is still when u equals 0, but 3 changes. Now let's change the value of u. It changes by 2, it changes by 2, so it should be negative 1 here. Wait. This one moves to here, this one moves to here, this one moves to here. So this one, no, this one moves to here, this one moves to here, so it's actually this one. So all the points can lie here if we let v equal 0 and change the value of u. Now, I think it will be the same though. So yeah. So here we can change the value of v, so it goes 2 up. I mean 1 up, 1 up. So if here is 1, we get this one. So this whole thing. So this is what we get when we transform 1 unit off for the green one. But this is the same thing that we get when we transform the red one to 2 units to the right. So actually they represent the same thing. So we just need to, so all the points lie in here. And so, yeah, so what I want to say here is all the points lie within this boundary, but none of the points, so all the points lie within this boundary, inclusive, but there is no point where, so every point within this boundary can be written in the form of 2u minus 3w, comma 3 plus 4w. And all the points that is in this form is within this boundary. So this is actually the smallest boundary that we can find. Now I'll count counterclockwise. So 2 plus 1 plus 3 and 4, that's 5, plus 2 plus 1 plus 3 and 4, that's 5. So we have 10 plus 6 equals 16. Our answer should be E. Let's check. What is this? Oh, yay, it is 16. I think my solution is really similar to number 1. But I don't really get this one. Yeah. Okay. So it's just the same thing. Yeah. So I think my solution and solution number 1 is very similar, but I mean, I think it's because it's like the most, I would say, conventional solution. So, and let's move on to number 25. Now I remember trying this problem, but I didn't have much time. I had like few seconds to try. That's not a pentagon. Oh, this is a great pentagon actually. I did it. Now, here's the center. And if it is the center, uh, 108, 54. Oh, what am I saying? 54 degrees. What is 360 divided by 5? 72. Yeah, so this is what we can do with problem 25, I think. So this is what we get when we draw it. Now we are going to fold it. Fold it, fold it, fold it, fold it, and fold it to get a pentagon here. And notice that these two lengths must be equal to each other when we fold them, or else it will not touch each other. That's what we know so far. We know the area of the large one. Now we need to find the smaller one. But I think if you find the ratio between the side lengths, then we can simply do that and get our answer. So maybe. Excuse me. First, we know that this length and this length are equal to each other because we folded them, and this is definitely a 90 degree. Oh, that is not feasible. Oh no. I will use different color. Maybe white. So this length are the same, and this is 90 degrees. Maybe. I think I started to see something. I see something in this. Oh wait, no way. Maybe this may lead us to the solution. And it actually does lead to the solution. Okay, let me try. Let's say that this length is A, this length is A, this length is B, This length is also B. Wait. We can use golden ratio, I think. So you know that if this is 1, this is phi. So this length right here is A times phi minus B. But how do you find the length of this one? Wait. Oh, I'm almost there. Like, I can sense it. I'm almost done with this problem. But I just cannot finish it. Similar triangle. Yes, it is similar triangle. We need to use similar triangle. This center. Oh, they share the center. They all share the center. Okay. I think I know how to solve it. Wait, then what is the length of... We need to find the length of this first. I forgot the length of this. Let's use the ratio again. Oh, no, never mind. It's 1 plus v. So this time, this plus this. So this whole thing, which was is A times v plus 1. I'm almost done. I'm almost there. Like, I just need to find the ratio. Okay, so what we have right now is a big pentagon. I need bigger ones. Like a huge pentagon. And oops, that's not a great pentagon. Yeah, this is much better. And we have I don't need to do that. We have this. And then this is a small the pentagon. And how do we find the one in the middle? Oh yeah, let me. So they all share the center. So we have a pentagon here. Now I'll just draw it again based on the drawing. Here. So we have a pentagon like this. Something. And then when we fold this one, when we fold it, we should get the one here. And we said that let this one be A and this one be B. Yeah, I think the drawing is correct. Yeah, precisely correct. You just need to find the ratio between this one and the whole thing. And we already found that this length is A plus I can. Hmm. I can feel it. I'm almost there. Hmm. Hmm. So, I don't know. Maybe I will erase it if it doesn't work. Will this help? No, but we need to use the fact that we can get this by folding it. So, we actually need to use the fact that this lengths are equal to each other. How should we use that? Whoa! These two are also equal to each other. Those four are all equal to each other. That means we just need to find the length of this. Oh, I feel like getting better in geometry. How do you find this? I did find it. But I don't want to use it. What am I saying? I did find it, and the reason why I don't want to use it is because we have to use law of cosine here. I don't. Wait. 100. No, I'm not doing this. I'm not using law of cosine here. But that seems like the only choice. This is 108 degrees. Okay, I will do it. Cosine 108 equals. To be honest, I forgot the formula to find this directly, so I have to do this. A squared over 2 times 1 minus cosine. Okay. So this thing is equal to root a squared over 2, 1 minus cosine 1/8. And we need to multiply it by 2, right? This length. So this thing is root 2a squared times 1 minus cosine 1/8 degrees. Eh? Wait. We didn't have to draw the big one. We could have just used... What am I doing? We could have just used this one right away. No, perhaps I was thinking, what if we could draw this and somehow prove that this length is equal to, like, this length are the same. Wait, but how do you compute cosine 108? Of course there's a way to do it. It is. No? It is not? Unfortunately, there is a way to do it. No, but actually, after finding the answer by doing this, I want to try and use the big one. Like, because, I mean, I felt smarter if when I drew the red, like, the big pentagon. So, the area ratio is 2a squared times 1. This to a squared. So, the area ratio is 2, 1. Let's calculate that. 108, 72. Cosine 108 is equal to yes. Cosine of 108 is equal to sine 18 degrees, which is equal to, right? Sine 72 degrees, right? Am I right? Why is it 72? It's not 72. 80 minus 62 degrees. Actually, I know how to find sine 18 degrees, and I don't know, like, this is equal to 18, then 5x equals 8. We can actually do this, like 90, and then do this, and then use, oh no! We can actually use the addition. So, actually, this turns out to be something that I knew, but I forgot. I knew the answer. It was 1 minus this, or something really similar to this. But I don't want to do all the process again, so I want a more clever way of finding it. Cosine 108. Cosine 108? Cosine 108 is equal to negative sine 18 degrees. But we decided not to use that. But I guess we have to do that. Let x equals 18 degrees, 5x equals 90. Sine of 5x equals 1. I forgot how to do this. I'm serious, like, I forgot how to solve it. I forgot how to solve this thing, this sine of 18 degrees. Oh no. I knew it. I forgot how to do this. Uh, no, why am I using this one? Oh, what? Ah, I had more space on the top. What? I cannot believe that. Okay. So we have sine alpha plus beta equals sine alpha cosine beta plus sine beta cosine alpha. So sine 4x plus x equals sine 4x cosine of x plus sine of x and cosine for... Wait, this is not how we do it. Ah, I cannot believe that I forgot the way to solve this one. It's okay, we don't have... No, actually, if we just find this, then we're done. That's quite unfortunate. I need to review. Okay. I think answer is B or D. Because this involves like golden ratio and stuff. I knew it. It's so frustrating when you knew something and then you forget something. Actually, I just found another way to do it. It's using this formula, but... And then using angle by... I don't want to do this. It will take too long. Wait, then... why don't we just... why don't we just try... No, I knew how to... Oh, wait, I think it came back. It came back to my mind. Sine 108, sine 18 degree. I remember splitting them, like... Whoa, what am I doing? Equals... like this. And then and then and then these two are the same, right? Because we have sine 2x, square. Huh? I forgot the official way of solving it, but I think this will also work. Squared and 3x. No, but we have to solve like a long equation if you're to do this. I really need to review. I forgot how to solve that. No, like I remember doing that when I was studying trigonometry. Uh, uh, okay, so we know that 3, I don't know, I'll just try, equals, uh, is this right? Cosine, sine cube? I think this is the right formula. And then sine 2x is equal to 2 sine x cosine x. Or let's move this one to the right side so that we have 2 cosine x. We will have sine squared 3x equals cosine squared 2x. Yeah. But the degree will be too large if you do that. Okay. This cosine 108 is hindering me. Let's try and use the bigger one. Because I think that is faster. But there's no way to prove it. There's no way to find the relationship between this one and that one. That's very, very, very unfortunate. I think finding this is easier. Okay, if we find this, we get our answer, so let's find cosine 108. Hmm. 嗯 out of all these, huh? Huh? $72. Wait, what? Did I do something? Oh, of course. Of course. I'm trying to find an easy, because I knew how to find this, but oh, maybe I should make a video for this today for the Olympiad in the series for my preparation, because I forgot how to do that. Okay. 126, 64. Cosine of this? Oh, I'm so sorry, everyone. I am so sorry. Oh, what? Okay, and here's the reason why I said I'm sorry. Let this length be 1, this one. We can find the length of this as golden ratio. So, 1, v1 plus v. Let's say this is v. This v. We can use this. We can use this. Then cosine 108. Why? Okay. I am so disappointed in myself that I couldn't think of this. Okay. So we have 2 minus squared over 2, 1. So two v. Is golden ratio 1 plus? Okay. So we have just multiply on all 4 on both sides, then we have. So our answer is simply this. And we just need to calculate this. Why? Eh? Wait, what is golden ratio? I forgot. I think this is not right. Let's stop right here and try and think. Okay, I forgot the golden ratio. I think it's root 5 minus. Is it this? Or is it root 5 plus 1 over 2? I think it is this one. Yes. Yeah. Okay. Then so we have 1 plus root 5 times. This is our answer. We just need to calculate this. How did I miss that? How did I miss that? Oh, sorry. This is much more messier than what I expected. Root 5 minus 3 minus root 5, which is 4 over we have minus 2 I'm sorry, my handwriting is getting worse. What is root 5 minus 1 squared? Is 6 minus 2 root 5 times root 5 plus 1. So this is equal to Uh, 10, 20. Oh, 5, 10. Negative 4. Our answer is root 5 minus 1. B. Ah! I'll be so sad if I get it wrong, but I mean, it will not be wrong, I think. I didn't have any mistake. Yeah. Oh, wait. Someone actually thought of, no. Someone actually thought of drawing a bigger, pentagon. Whoa, nice. Wait, I couldn't proceed further from here. Oh, wait, so this actually works. Nice. Wait, but no one has my solution? Yeah, no one has my... Whoa, this is not right. Yeah, then my solution is the new solution. I will be uploading a new solution here. Yay! I mean, it took a while to solve it, and the reason why it took a while is because I couldn't calculate a cosine 108 degrees. But why couldn't I think of the golden ratio at first? Yes, I will study more and come back. Thank you, and thank you for watching my mock test. I think if I take it a second time with other tests, I might get higher score because it's been a while since I solved AMC 10 problems. So maybe. I will try again later. Thank you, and see you later today. Bye.